so let's go ahead and get back on track. We're at 4.6 now. So in 4.5, we talked about side, 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 and side, angle, side. We're going to learn three more things. One is the angle, side, angle, 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 side. Okay, so these are obviously conditions for congruence. And then there's the mysterious HL. Okay, so we'll get to that when we get. So let's go ahead and go ahead and do the angle, side, angle. Okay, so let's go to page 260 in the middle. There is a postulate there that says angle, side, angle. If two angles and the included side, so that's why it's angle, angle, side, right? So it's angle, side, angle, right? Angle, side, angle, angle, side, angle. So if these are the same, you're going to have a congruent triangle, right? Okay, so that's what they're saying, right? So this angle, so if I had another angle that looks like this, and I can prove that this side and this side, this angle and this angle, this angle and this angle are congruent, so I would have angle, side, angle, angle, side, angle, and the two triangles would be congruent, okay? That's what they're saying there. All right, so let's go ahead and go to example number one. Example number one. Organizers of an orienteering race are planning a course with checkpoints A, B, and C. Does the table give enough information to determine the location of the checkpoints? Okay, in other words, can we say that the triangle is set here? Okay, so I have A to B. So let's say A, B, we have C here. A to B, the distance here is 7.6, okay? And then we have what? We have the anchor, okay, okay. So that the bearing is north 55 degree east. So okay, now I know what the bearing is. So let's go ahead and this again. So the bearing, when you talk about bearing here, bearing always starts from the north here. You go from north, you're measuring the angle here. So you have north 55 east. So north, now we're going to the east at 55 degrees. So it's going to look like this, where this guy here is 55 degrees, and this is 7.6 kilometer. This is A, this is B. Okay, and then I have B to C. B to C is north. Then we're going to go to the west at 26 degrees. So go ahead and move this guy down here. Okay. I'm going to go from here, northwest 26 degrees. This guy here is 26 degrees, and this guy is C. And I know that the distance, I do not know what the distance here is. Okay, and then I have from C to A, C to A is south 20 degrees west. So it's going to be south 20 degrees west. So it's going to go like this, where this guy here is 20 degrees. And this guy here is going to be C, right? From here, it goes south to west 20 degrees. So since this is 20 degrees, this guy here is also 20 degrees, right? Okay, so what do I have here? What do I know? I have this is the only length that I know. I know this angle here is going to be 55 minus 20, so it's going to be 35 degrees. I know what this guy here is. This is 35 degrees. And this guy here, since this is 55, this is 55. 55 plus 26 is 81. So this guy here has to be 99. Did everybody follow that? Let me go ahead and do this in color here. So I know that this guy here is 55 degrees, right? This guy here is 55 degrees. So from here to here is 55, which means that here to here is 55. Here to here is 55 degrees. Okay, and I know that these three angles have to add to 180, right? And so since I have so 108, so if I'm trying to find this guy here, it's going to be 180 minus 26 minus 55, which is going to be 99 degrees. That's how I found that 99 degrees, right? So I know that this guy here is, from here to here is 55, but I have to take it 20 degrees away. So here to here is 35. So I have an angle, side, angle. So point C will be set. There's no other way that C can be set. The triangle is there. Okay, that would be the answer. Okay. Example number 2. Example number 2, applying ASA or angle side angle congruence. Determine if you can use ASA to prove that UVX and triangle UVX is congruent to triangle WVX. And I have a situation that looks like this, where I have X VWU, and I'm trying to prove, okay, what am I given here? I'm given that this guy and this guy are congruent, okay? I'm also told that this is 90 degrees, so which means that this guy has to be 90 degrees, correct? So if we look at this triangle, I can say that angle, side, angle, and from this triangle, I have angle, side, angle. So yes, they are congruent, right? So the way you would word this is that angle WXV, so angle WXV is congruent to angle UXV. Okay, and I also know that UXV is shared. I also know that this angle, these are both 90 degrees, right? So I have angle UVX is congruent to angle WVX, right? So I have a angle, side, angle, angle, side, angle. Okay, they're congruent. Therefore, this triangle, these two triangles are congruent. Okay. Flip the page. Go to angle, angle, side. Angle, angle, side is the same thing as another way to say prove that the triangles are congruent. So far we did side, 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 angle, side, angle, side, angle, and now we're going to look at angle, angle, side. Okay, angle, angle, side. There's a theorem there on top of page 262. Okay, it says if two angles and a non-included side of the triangle are congruent, then triangles are congruent. And this is pretty simple, really. Okay, if you think about it, if I have two triangles that look like this, right? If I have an angle, angle, side, angle, angle, side, right? Since the total of the triangles angles have to be 180 degrees, basically what I'm saying is that this guy here is going to be the same as this guy, right? Because it has to be, because I have these two angles are the same. when I subtract it from 180, the final angle is always going to be the same. So it's kind of a subset to angle, side, angle, right? Because angle, side, angle, right? It ends up being angle, side, angle because the other two here are the same. Okay, so angle, angle, side is, you can really think of it as a subset to angle, side, angle. Okay. There we go. So let's see if we can use this and do example number 3. We have a situation where we have 2 parallel lines here. So this line and this line are parallel, which means that what? Which means that, okay, given that those are parallel and BC and DC are congruent, so I know that BC and DC are congruent, A, B, C, D, E, and I am told that these two lines are parallel. I already marked that, and I have BC and DC. BC and DC, these two are congruent, right? So what do I have here? I have that these two angles are congruent because they are vertical angles. I also know that these two angles here are congruent. They're congruent because I have 2 parallel lines with a transversal here. These two are alternate interior angles. Therefore, they are congruent. And I'm going to have angle, angle, side, angle, angle, side. Okay, so that's why these 2 triangles are congruent. Okay, all right. All right, last but not least, we have the HL situation. We haven't done any H's or L's, so I'm going to go ahead and give you a hint, and maybe we can work this out. H stands for hypotenuse. Hypotenuse. Is there something in between hypotenuse? Oh, I'm missing an E. Hypotenuse. Okay. L is a leg. Okay. So anybody remember when we talked about hypotenuse and legs? In what situation do we talk about hypotenuse and legs? Anybody?
Isn't it?
Huh?
You're trying to find the hypotenuse.
Yeah. So when do you do? What is the equation that you use for hypotenuse?
A squared plus B squared equals C squared.
Exactly. A squared plus B squared is equal to C squared, right? This is when we look at the hypotenuse. But this only works in a certain triangle. What is that?
A right triangle?
Correct. It only works in a right triangle, right? It only works in a right triangle. So if I have a right triangle like this, right? And I have 2 of them, okay, I have 2 of them, all right? And I know that the hypotenuse is the same, and one of the legs are the same, all right? In reality, what am I saying? Since it has to satisfy A squared plus B squared is C squared, if I know that the hypotenuse is the same and one of the legs are the same, the other leg naturally has to be the same, correct? Because it has to satisfy this relationship, right? Because I know what C squared is, I know what A squared is. B squared is always going to be the same, no matter if the other A squared is the same. Okay, so this is really, again, okay, so HL only works in 90-degree situation, right? So this only works in a right triangle. It has to be a right triangle, okay? All right, and it's really a subset of side by side, right? Because since you're setting the 2 sides, automatically sets or determines the other or remaining leg or remaining side, right? So it's really side, 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 side. Okay? So HL, hypotenuse leg, works only in a right triangle, and it's really a special or a subset of side, side, side. Okay? So let's see if we can do example number 4.
Mr. On,
Yes.
Reeve got kicked out of the Zoom. He's in the waiting room.
I've tried to cue him in a couple of times here, and he's still not getting in.
Okay.
All right, thanks for letting me know, though. I appreciate that, and I'm sure Reeve appreciates that. Okay, so example number 4. Example number 4. Determine if you can use the HL congruence theorem to prove the triangles are congruent. If not, tell what else you need to know. Okay, so I have a situation where I have, so I have a situation where I have a right triangle. I also have a right triangle. So this guy is a right triangle, this guy's a right triangle. And V, Y, W, X, Z. Okay, so determine, so triangle V, W, X, and triangle Y, X, W. So V, W, X and Y, X, W. Okay, so these two large triangles right here, right? So I have 90 degrees, okay, and I'm sharing the hypotenuse here, right? WX is a hypotenuse for both, okay? I'm also told that this guy and this guy are congruent. Well, there you go. I have hypotenuse leg, right? Hypotenuse leg, right? So VWX, hypotenuse and leg, and then YXW is hypotenuse and leg. Are they corresponding properly? And so I have V, so it'd be Y, that's good. Then I have W, V, W, the short side, Y, the short side. Yeah, we're good. So yes, as a matter of fact, these guys are congruent, okay? And then we're gonna talk about, in B, the triangles VWZ and triangles YXZ. So these small triangles here, right? These small triangles here. Okay, I know that these two are the same. Okay, I know that these two are congruent. I know this angle is congruent, but I also know that this guy here is congruent. Why are those two are congruent? Because they are vertical angles, right? So I have angle, angle, side, angle, angle, side. So from the angle, angle, side, I can say that the two triangles are congruent. Let's see if they are corresponding properly. X and Y, V and Y, I'm sorry. Then V to the longer is W, so Y to the longer would be X, and then we're Z. Okay, so good. So yes, these guys are congruent, but this guy was congruent to HL, whereas this guy was congruent to AAS, right? Well, okay, well, let's see. Okay, let's read what B says. This conclusion cannot be proven by HL. That's correct, right? It can be proven, but not by hypotenuse leg. It can be proven by angle, angle, side. Okay, now it looks like I am going over something that the book is not going over. Okay, the book says, book is correct. in saying that you cannot prove this using hypotenuse leg, okay? All right. But you can prove it by using angle side. All right, we're done with 4.6, okay? So in conclusion, in 4.5, we learned the congruence of side, 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 angle, side. And then in 4.6, we learned angle, side, angle, angle, side, and hypotenuse leg. Okay, so there are 5 of them we learned: SSS, SAS, ASA, angle, side, and hypotenuse leg. Okay, so those are the 5 triangle congruence conditions that we learned today. All right. Your homework for today. For this section, the homework is going to be 4 through 17, 26 through 29. Okay. So you can start working on that.